Okay, here we have four people lining up for a photo. Alice, Barry, Chelsea, and Doug line up for a photo. And how many unique photos are possible? So this is our introduction to counting, and also our introduction to something called the fundamental counting principle that we'll see materialize throughout this video. So if we have four people standing in a line, you can think of it as four spaces, and we have to pick who's going to stand in that leftmost position. So of course, what are our choices? Well, we could either have Alice stand in that position, Barry, Chelsea, or Doug. And I should add, what we're filling in here is called a tree diagram, which is really useful in counting, at least in the early stages. So let's clear all this off. So there's the first part of our tree diagram, which remember is keeping track of all the number of possible photographs, arrangements of these four people that the photographer could decide upon. So after we pick somebody for the leftmost position, we go to the next set of branches in our tree diagram. And of course, after we pick the first person, we only have three people left. So if we pick Alice for the leftmost position, our first selection, we're left with B, C, or D. And if Barry stands in the leftmost position, then we could either have A, C, or D left for that second position. And then if we pick our names here, Chelsea for the leftmost position, then either Alice, Barry, or Doug, of course. And I better not take up too much space because we're going to need it, as you'll see in a few more minutes. Then we're left with what Alice, our second choice could have been Alice, Barry, or Doug. And if Doug is in that leftmost position, our choices in this, I guess, for the second person in this lineup would be what? Alice, Barry, or Chelsea. So let's just keep track. Right now, we've already decided our four possible options or selections for that leftmost position, and now we've already exhausted the possible options we have for that second position in our photograph, and now we're going to our third set of branches in our tree diagram. And it should also make sense if we have four people to choose from. Our tree diagram is four branches initially, and then for every branch it triples. We have a splintering off of three little sub branches in that next stage, representing the three remaining people. And now, of course, two branches splinter off at this third stage of our tree diagram, representing two people remaining. And this is where it gets a little bit hard to keep track of the letters, but we'll do our best here. A, B, we're left with C and D left. And this is options that we have, or I guess the photographer has for that third slot in our lineup of four. And if we have AC, we're left with what? BD. And if we have AD, we'll be left with BC. Now let's just keep going here. BA, we're left with CD. BC, that is A and D. And with BD, we're missing A and C. If you're having problems keeping track of all these letters, just write down A, B, C, and D and maybe cross off what you've already used up, but I'm sure you can follow here in the video at least. CA, we're left with B and D as our third choice. Pair of options for our third choice. CB, we're left with AD. CD, we're missing A or B, and thankfully we're now to the last part of our third selection. DA, we're missing either B or C, and DB, we're missing A and C, and DC, we're left with Alice or Barry. Okay, and now we're on to our final stage of our tree diagram, thankfully, and that corresponds to the last remaining position in our photo lineup. And it probably makes sense that if we've already used up three choices, we only have one person left. And we can see that if we have A, B, C, we're only left with D left. And if we have A, B, D, and make sure you know how to count, or not count, sorry, follow your tree diagram. If we try to get to this D, we can see that's A, B, D, followed by a C at the very, very end of it here. Okay, and a nice little pattern emerges here. If we just swap those last pair of pink letters, we can finish this tree diagram off a lot faster, but we'll go through one more set of branches here to make sure we're clear. A, followed by C, followed by B. We're missing D. It's our fourth and final choice. A, C, D, we're missing B. And we can see that the flipping of B and D is exactly what we need to do there. So let's do that and finish this tree diagram off, and then start to try to find a shortcut to all of this. C and B. So again, if we flip the pink, we get the final stage of our tree diagram, and that's going to be D and C, I think. Yeah, D and C, and then that's going to be DA, followed by CA. And then B and D will switch to DB, DA, BA, CB, CA, and home stretch, finally, BA. Let's just make sure this works again one last time. DCA, we're missing B, check. DCB, we're missing A. Okay, so there it is. There's our tree diagram, and I'm sure you've noticed that we start off with 4 branches, correspond, of course, to the 4 possible people we could pick in that leftmost position. And then what happens when we go to the second choice, each of those branches, of course, triples. And then that corresponds to 3 people that we have for our second blue position. And then we have 2 people remaining, followed by 1 person remaining. And if we count these up mindlessly, all these different options here, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There's 24 possible photos. Okay, so how do we get 24? How can we predict how many branches our tree has here? Well, of course, with a hint is here. If we understand that we have 4 options in our first choice, followed by 3, followed by 2, followed by 1, something called the fundamental counting principle says, you know what? You just have to multiply those options together, and then you don't have to spend 10 minutes creating this tree diagram, which incidentally would be completely unmanageable if you had any more than 4 people. Honestly, even if you've had 6 or 7 or 8, it'd be too time consuming and really hard to manage. So let's write this down. This is called the fundamental counting principle, and we usually just abbreviate that via the FCP, fundamental counting principle. And remember what it is to multiply your different options that you have. So let's just illustrate using these 4 spaces how we can use the fundamental counting principle to predict what would happen in our tree diagram. Well, remember our first choice, we could have picked A, B, C, or D. So there's 4 possible choices. So let's keep track. I like to keep track of like what I call a hypothetical when we're going through our fundamental counting principle. And that hypothetical is, what if we pick Alice to stand in that leftmost position? Well, guess what? It leaves B, C, D left for our second choices for our second position in our photo lineup. And let's keep that hypothetical going. Maybe we pick Chelsea to stand in that second position, and then we're left with B and D, which of course corresponds to 2 choices. And then maybe we pick, Doug to stand in that third position, and that leaves us with only Barry left to stand in that last position. Of course, this corresponds to 1 choice. And the fundamental counting principle says, you know what, if you multiply those 4 different possibilities, I guess, that would be your total number of photos that we could have using 4 people. So please be aware, if you're wondering why we took the time to go through this tree diagram, the tree diagram illustrates this multiplicative property of the fundamental counting principle, the fact that our 4 branches triples and then doubles, and then we're left with a single branch, which is why we're multiplying here. So fundamental counting principle is extremely important, and it's essentially, you can just boil down to telling you to multiply your different numbers that you can have that are quite often easy to see if you think of one hypothetical situation as illustrated above.